be looking at probability. I don't think we are unfamiliar with probability itself because we have touched upon it before. However, we touched on probability when we were in Sec 2. Okay, are we ready to start? Alright, so let's just do a very quick recap about probability, okay, especially when it comes to certain terms that will commonly be seen and used, okay, in this chapter itself. So looking at 2.1, everything that is in 2.1, I'm sure you have learned it before in Sec 2. It should be rather intuitive by now. Okay. However, you may not have remembered the terms itself. Okay, so just a recall and recap about what a sample space is. Sample space is basically a set of all possible outcomes. Of a probability experiment. Okay, a probability experiment is anything that you use a probability to guess. So for example, rolling a die, okay, or tossing a coin, all those are what we call a probability experiment. So as an example, okay, for the probability experiment of tossing a coin, okay, we know that our coin, when we toss it, there's either heads or tails only. Therefore, the sample space for tossing a coin would be a set, okay, because sample space is a set. So we use set notation to describe it, okay, or either getting a heads or tails, okay, because those are the only possible outcomes. On the other hand, if you're looking at throwing a die, the possible outcomes would be 1 all the way to 6, 1, 2, 3, 4, 5, 6. So that sample space itself would consist of this set of numbers. Okay. Then back in Sec 2, we also touched upon the word called an event. So an event is a subset of a sample space. Notice over here that although we have come across these words when we were in Sec 2, okay, we did not quite relate it to the idea of set before. Okay, it is actually because set itself is only touched upon in Sec 4. Right, so now that we have actually understood the whole idea about set already, we may be able to appreciate better, okay, all these terms, sample space and event. So for example, an event, okay, like throwing a die, as in the probability of experiment of throwing a die and then getting a multiple of 3, for example. Then the event itself, okay, subset of the sample space. So the sample space itself is 1, 2, 3, 4, 5, 6. In this particular event, we are looking at getting the outcomes of 3, 6, and 9. Okay. Okay. Oh, sorry. Thank you. My bad. Sorry. Thank you for pointing out 3 and 6. Thank you. Okay. So, which explains why, when it comes to finding the probability of an event, right, which we could actually denote it as a capital letter P for probability, E for event. Okay. Although sometimes when in Sec 2, the event itself, we will describe it in words. So for example, probability of getting multiple of 3. When we roll a die, so there are 2 possible outcomes only, okay, for that particular event, but the sample space has a size of 6, so we are looking at 2 out of 6 probability, and that is 1/3. Okay. So 2 out of 6 itself, looking at the number 2, okay, is actually the number of elements in the set E, whereby E is the outcomes of the event, the favorable outcomes of the event. What color should I use? And then 6 is the number of elements, okay, in the sample space. Okay, so sample space usually we denote it as S. Okay. So these are things that we are familiar with already. This formula itself is just the one that is used in the textbook, but honestly I never really quite memorized this formula, because usually you just know how to count, okay, and get the number. That's good enough. We don't really need to really apply the formula itself. Okay, I'm just formalizing it all together. Then in Sec 2, we also encountered, okay, so we also encountered the idea of complement actually. So the probability of not E. In this case, I'm looking at the event of getting a multiple of 3. So we are looking at the probability of not getting a multiple of 3. Okay, and we know that out of 6 possible outcomes, not getting 3 and 6 would mean that there are 4, so that probability itself is 4 over 6, okay, which is 2/3 mark, right? But another way, instead of counting it like that, okay, we also learned in Sec 2 that not E is the same as 1 minus the probability of E, right? So these are things that we have covered in Sec 2 before to find probability. Okay. Any questions at this point? Don't expect you to copy question. I've seen it a few times already. Okay, I just write it down for the purpose that I have a visual representation to tell you what I'm talking about. Okay, so let's look at practice now 1. Practice now 1 is definitely a question that we are capable of doing, okay, at this point, because we have covered it in Sec 2 before. Alright, so just a very quick recap. Okay, we are choosing a letter that's chosen at random from the word clever. Okay, Part I wants us to list the sample space in set notation. Okay, so that means out of this word itself, we have 6 letters. I pick 1 letter out of it. Okay, notice that there are 2 E's over here. We need to distinguish these 2 E. Okay, so just like how we understood about how elements in a set needs to be well defined, okay, and distinct. Okay, therefore, when describing our sample space in set notation, we will write it as CLEBER, but I cannot write it like that because I need to distinguish the E's, so I write it as E1 and E2. Okay, so sample space, keeping consistent with the idea, the definition that it is a set. Okay, so that's why we use set notation. Okay. And looking at part 2a, we want to find the probability of choosing an E. Okay, so now that we have the sample space already, and that's a total of 6 letters, okay, what would that probability actually be, Jasper? What's that probability for choosing an E? We have 6 letters. Put my hand in, take 1 letter out. What's the probability of that? Sorry? 1/3. How do you get 1/3? 2 out of 6. Okay, so because it is 2 letter E's out of 6 possible outcomes, that simplifies to be 1/3. Okay? What would the probability of choosing a C then actually be? Sixuan? 1 out of 6. Okay, so there's only 1 letter C, so 1 out of 6. Okay, part C. We want to find the probability of choosing a C or an R. What would that be? Regine Chong. Where is Regine Chong? Oh, okay, yes. 1/3. Okay, so 1/3 because we have C and R, 2 letters out of a total of 6, so we have 1/3. I just realized that Regine Chong look a bit similar to Chloe. The specs, yeah. But it's, the parting you also have same, yeah. Then the uniform also same. So I will confuse now. Or maybe when you remove mask, then I realize the difference now. Okay, then I can see the distinction, and I can define the things in the set properly. Okay, next one, part D. Probability of choosing a T, what would that be? Sixuan? Yes. 0, right? Okay, so straightforward. There's no T over here. Okay? Then looking at part 3. Okay. The part 3 says that by using set notation for the respective events, find the probability that the letter chosen is a vowel. Okay, so let me just write down the question first. Okay, let's understand what the question is actually trying to say in the first, at the start of the question. It says by using set notation for the respective events. So an event itself is a subset of the sample space. Okay, so what the question is asking you to do is to list out what are the favorable outcomes for this event itself. Okay, so for choosing a vowel, in this particular case, we only have 2 vowels, the E1 and E2. So that means that the event, okay, that we're looking at is E1 and E2. Okay? And therefore the probability of choosing a vowel will be 2 out of 6, which is 1/3. Okay? Okay, this E stands for event. Okay, event of choosing a vowel. So maybe if you don't want to write E, you can say event of choosing a vowel. Also can. Then in part B, Okay, Matthew? Okay. So part B, probability of choosing a consonant. Okay, there are two ways that you can solve. In this question itself, you may want to go about counting how many consonants are there. So that is actually one way to actually solve. So the event itself will be the subset CLBR. Okay, and then we find that there are 4 out of 6. Okay, as a probability, which is 2/3. So this is one way that you can do by literally counting. We know that sometimes it's not possible, especially when we are going to further this idea of probability into combined events in this particular chapter. You will find that it may not be efficient to always do counting. Okay, later on when we reach that stage, I'll show it to you. Okay, so what we can do is to adopt the idea about how we have 1 minus the event, the probability of the event, to find out what is the complement. Consonants and vowels are actually complements of each other. You cannot have a consonant that is also a vowel. Okay, so therefore, we can do 1 minus 1/3 to get 2/3. Alright? So this idea, I'm confident that you already know. Okay. However, despite my confidence, I just want to check also any questions. Yes, use it. Do we need to write the event? You need to, because in this question it says by using a set notation for the respective events. That's why I need to write. But most of the time, I never encountered like that before. Okay, they don't usually ask you to write it out. Yeah. But I have ever seen an exam question asking to list sample space. Yeah. Despite it being very rare. Yeah. So I think that we need to know what sample space means so that you know how to write it out like that. Yeah. Okay. Okay. Could I erase this out of the whiteboard already? Thanks. So that's for 2.1. I will not go into the practice now 2. Okay. That one I'm sure you can do it on your own. Right. Chapter that we're looking at in Set 4, right? Okay, what is the difference? The difference is that we're looking at combined events. Combined events will mean that we're trying to find the probability of one event after the other. So for example, if I have 2 dice, okay, and then I roll it, okay, what is the probability of me getting maybe the combination of 1, 4? Okay, we definitely know how to find the probability of getting the number 1, alright? But what about the combination 1, 4? Okay, so this is where we are combining 2 events together, 2 different die, into one situation to find the probability. Okay, so the first thing that we're going to learn is to learn how to draw possibility diagrams. Okay. Okay, so take note, it's possibility diagram, not a probability diagram. So let's consider an example. So let's, like I said earlier, rolling of 2 dice. Okay, we know that one possible outcome when I roll 2 dice is to get the outcome 2, 3. Okay, the outcome 2, 3 when written like this, okay, like a coordinate form, what I'm trying to say is that 2 is the number that we're getting for the first die, and 3 is the number that we're getting for the second die. Okay, even though I can have 2 die that look exactly the same, I need to draw a distinction between them. Okay, so I need to recognize one of it is first die, the other one is second die. Okay. So therefore, the outcome 2, 3 is different from the outcome 3, 2. Okay, 2, 3 and 3, 2, of course, looking at it just on the surface level, it does look like it's giving you the same goal, okay, same idea, same outcome, right? But then they are actually different in the context of probability. Because 3 itself is the one for the first die, and then 2 is the one for the second die. Because each die can give you 6 different numbers, so if each die giving 6 different numbers, when you have 2 die, it will produce for you 36 different outcomes. 6 times 6. Okay, how do I know that? This is where I introduce to you the possibility diagram. Okay, a possibility diagram essentially is like a graph lah. Okay, whereby I will label this first die. It doesn't matter whether you label second and first here or first and second. In case you're wondering why do I spell die as D-I-E and not D-I-C-E, hope you know die is singular, dice is plural. If you don't know, okay, good news that you're learning this at 16 and not later on. Okay? So, first die and second die, okay? So, each die we got 6 different outcomes, alright? So, we will label it the 6 different numbers for the first die. Second die also. Sorry, we not have it equal. I suggest that you don't draw it too neatly on your notebook. You get the idea will do. Otherwise, you take forever to draw it neatly. Okay. So to represent one of the outcomes. Okay. So let's say 2, 3. Okay. It's possible to have first dice 2 and then 3 over here. We will use a dot to represent it as a possible outcome in this experiment. So the entire possibility diagram for this question is just a total of 36 dots. That's why I don't suggest that you draw it too neatly. Get the idea will do for your notes. But let me try my best to make it neat over here. Okay, so each dot represents each outcome. So a possibility diagram is a visual representation of the sample space. Questions at this juncture, right? A possibility diagram, there are many ways to draw possibility diagram, but this is one of the few. Okay, there's another one whereby we do addition, subtraction, multiplication, or division, that kind. That one looks like a table. Okay, then also a visual representation of a sample space need not just be possibility diagram. Later on, we also learn tree diagrams. Okay, so the fundamental question here is, why are we drawing a possibility diagram? Okay, what does it help? Alright, earlier on, I mentioned that these two outcomes are actually different. If let's say I want to list it out in set notation, okay, if I want to list out all the possible outcomes, that means the sample space in set notation, what it will look like, okay, for this particular situation is that I literally have to consider every single thing. And this will definitely tire yourself out. Right? Okay, even I myself am giving up now. Alright, so I think you get the idea. Okay, so it will be a very long list. Okay, if you want to write out the full sample space itself. Okay, which explains why a more efficient method is to represent it in a possibility diagram. Sorry. Okay. So let's make use of this possibility diagram. Let's look at work example 3. Okay. For example 3, it is already found in your textbook. The answer is already there, so I'll just run through it. Leave it up to you whether you want to take any notes or not, or just directly write in your textbook. Okay. So in this one example 3, they want you to make use of the possibility diagram that we have just drawn, okay, to determine the probability that both dice show same number. Okay, if you actually really write it out in set notation, it is a sea of numbers, very difficult for you to go and find the thing that you want. Right? Maybe for same number is easy lah, okay, but if you want a different combination, then it will be difficult, especially let's say in part 2. Okay. However, in a possibility diagram, it definitely makes things easier because for same number, we just look across the diagonal. Okay, because that is where we have 1, 1, 2, 2, 3, 3, and all the way to 6, 6. So the numbers that we want are these 6 outcomes. Okay, and just by counting it itself, we know that there are 6 over 36, which explains why the probability is 1 over 6. Okay. Then in part 2, right? Okay, we want the probability where the number on the first die is bigger than the number on second die. Surely if you write it out, it will be a headache to go and find these numbers. Okay, but from here, what we can do is, let me get a green marker. What we can do is, first die is over here. We want numbers that are bigger than this one, okay? So this one surely cannot, but we know 2, 1 can, 3, 1 can, 4, 5, 6, okay? And then this one cannot. So once you get the hang of it, you will realize that they are actually all the numbers on this part of the triangle, okay? And then you can count that will actually be a total of 12, 13, 14, 15 outcomes. So answer will be 15 over 36, and not forgetting to simplify, you get 5 over 12. Okay? Questions so far? Alright? If no questions, I want you to give practice now 3, textbook page 40, question 1. Okay, I want you to give it a try. Draw your own possibility diagram. Take note that it is a tetrahedral die and a 6-sided die. So, maybe to start things off for you, up to you how you want to label, but actually don't need the arrow sign, sorry. The arrows means that it goes on. That heavy. Okay, so 1, 2, 3, 4, 5, 6. This is for the 6-sided die. And then for tetrahedral die, the outcomes are 1, 2, 5, and 6. So read the question carefully. Okay, fill in the dots yourself and solve the question. Okay? I'll give you 5 minutes to do this. If you still don't understand anything, raise your hand, I'll come to you. Okay? for probability, you must know that it can only be from 0 to 1. So definitely it will be a fraction of decimal. Okay, it cannot be more than 1. That's our understanding of probability, right? Okay, probability cannot exceed 1. Okay. Shall we go through our answer? Okay, what's the probability for both guys having same number? Let me just complete my possibility diagram first. Okay, what will your answer be? Let's see, Joshua. Yes, what's your answer? For part A. Joshua, is you right? Oh, you. Sorry. Then Josh is him. Oh, okay. That's confusing. Yes. Part A. Probability of both dice showing same number. Sorry? 1/6. How do you get 1/6? 4/24. Okay, so we get 4/24, that's 1/6, that's simplified. Okay, part B, we want the tetrahedral number to be bigger than the 6-sided die. Okay, and what will your answer actually be, Cheyenne? What's your answer for part B? Haven't do? Okay, so can you count for me now? Alright. What are the dots that has tetrahedral, that means this one, bigger number than the 6-sided one? You do a count, you got draw, right? This one, you count now. Okay, so the circled ones are the 10 in total, so 10 out of 24 dots. So that simplifies to 5/12 as our answer. Okay, and then part C, we want both prime. Is 1 a prime number? 1 is not a prime number, yeah? Okay, so therefore, the ones that we should circle, okay, both primes will be 2, 2, 3, 2, 5, 2, and then this 5, 2 over here, 5, 3, and 5, 5. So 6 dots in total, okay, out of 24, that will be 1/4, okay, as our answer. Alright? Now let's move on to look at question 2. Okay, so enough of rolling dice, let's look at picking cards instead. I shall only write down a summary of the question. I won't write the full question, okay? So, looking at question 2 that's in your textbook, page 40, it says that a bag contains 5 cards and the numbers are 1, 2, 3, 4, 5. A card is actually being drawn at random. That means it's fully blind, you just pick one card, okay? And its number is being noted. That means you take note of what is the number on that card, okay? The important part of this question is that it says the card is then being replaced. Okay? At this juncture of our probability, we are not looking at whether something has been taken out, that means never put back. Okay? This idea of is then replaced means that you take out already, you put back. Okay? So whenever you pick, okay, from the bag itself, there are always 5 cards to choose from. Okay? Later on in this chapter, then we'll look at what if I never replace. Then definitely the probability will change. Okay? So the card is then replaced. That means constantly there are always 5 cards in the back. Okay, and then after that you take out a second card, and then the number is being noted again. Okay, question asks you to use a possibility diagram to find the probability that the number shown on the second card is greater than the number on the first card. I'm just writing in short form over here. Okay, so to draw this possibility diagram, we're looking at 2 different events, okay, whereby we have our first pick, our first draw, and our second draw. Again, it doesn't matter how you label the axis. Okay, you can have it the other way round. It is actually that it doesn't matter actually. Then again, no need the arrow sign yet. Okay, we have 5 cards all the time. So your possible outcomes will be a total of 25 dots. I think my dots here are slanted. That's because I will have parallax error. Okay, so based on that possibility diagram, to find the probability over here, second card bigger than first card, we will have to look at these numbers here. Okay, these numbers are bigger than 1. We circle it out. Then we continue to do the same. And we have a total of 10 dots that are being circled. Right? So probability is 10 out of 25. Answer is 2 over 5. Okay. So this question, nothing new, can be definitely solvable if you understand what we've been doing so far. The thing that I want to go through is part 2. Part 2 says that we want to find the probability that the sum of the 2 numbers is greater than 7. Okay? And then maybe also just write them down part 3 lah. Okay? Let's write it out. Here. Says you want to find the probability of the product of 2 numbers greater than 10. Okay? Now why do I want to place emphasis on these 2 parts of the question? Notice that sum and product, okay, is being required, okay, to answer the question, but your possibility diagram over here has its limitation. Okay? It doesn't tell you the sum, it doesn't tell you the product. Okay? It means that you have to individually go and count everything before you can go and decide your probability itself. Okay? So this possibility diagram is not helpful for sum and product. Then we need to switch out our possibility diagram, okay, to re-represent the sample space that we're looking at for the experiment or for the event. Okay? So the other way of drawing our possibility diagram is to have it in table form. Okay, maybe you can skip the border if you want to. Okay, so you want to skip the border. Okay, essentially now we're looking at plus sum. Okay, of 2 numbers. So you have your first number over here, second number over here, or the other way around also can. Okay, first draw and then second draw. Okay, numbers are for 1, 2, 3, 4, 5. It's not enough space. This one is definitely more tedious. Okay, then 1, 2, 3, 4, Okay? So we restructure our possibility diagram, addition, okay, then we need to add it up, unfortunately. Okay? But usually the numbers are simple, don't really need calculator. So if you tell me 1 plus 1, you need to press calculator, I'm rather worried. Okay, so 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9. Okay? Because the numbers are fairly easy, you should be able to do it fast if you notice the pattern. It's an increment of 1 throughout. Okay? Right, so with this possibility diagram, then now it's easier. It facilitates our finding of the sum of two numbers that are more than 7. So we go and find what are the numbers that are more than 7. These are the ones. Unfortunately, it takes a lot of effort just to find out what are these 6 numbers. Okay, so too bad, we just have to live with this. Okay, 6 out of 25. That's simplified already. So that's our answer. Okay. Then with that same idea, we do it for product. Okay. So now instead of addition, we do the product one. Then now we can find the product of two numbers that are more than 10. That would be this. Okay, 8 numbers in total. Therefore, answer is 8/25. Any questions? Do you all find this tedious? Tedious, okay. Especially if you want to draw it neatly. Alright. But then possibility diagrams is there's a possibility of possibility diagram coming out one. Okay. The probability of it is not 0. So we need to know how to draw. But usually knowing Cambridge, okay, they will usually already print out for you, they ask you fill in the blanks. Okay, they usually won't make you go and draw the whole thing. Yeah. I think Cambridge has been very nice in recent years. Okay. Seeing that we only have 5 minutes, I think I shall not go on. Okay. Tomorrow I will continue with just one more question of possibility diagram. Then we move on to 3 diagrams. 3 diagrams are slightly more complicated. Okay. But once you get a hang of it, it's rather easy. 学箭哦。